Okay, for this lesson, we're going to take a look at solving quadratic inequalities with one variable by using sine analysis. Another form of this can be referred to as interval analysis. So when we're talking about sine analysis, which we can do using either sine chart or test intervals, we're basically figuring out whether the function would be positive or negative, and we're going to apply that towards the solution regions that we would see if we did it on a Cartesian plane. So if we take the first example from the last lesson, where we did our case studies, then we're going to use the same example, x squared plus 2x minus 8. Where if I said that I had the function with the equation y is equal to x squared plus 2x minus 8, then I know that the zeros of the function are going to be negative 4 and 2, which we can see here and here. When we're looking at the region where x is less than 4, which is going to exist over here, we can see that the function is positive or above the x-axis. When we look at the region in between the two intercepts, in here, we can see that it's negative or below the x-axis. And then when x is greater than 2, it's positive or above the x-axis again. So if I take the intervals for these regions, when x is less than negative 4, when x is between negative 4 and 2, and when x is greater than 2, then I can see that when it's less than negative 4, it's going to be positive. When it's in between the two, it's going to be negative. And when it's greater than 2, it's going to be positive again. This means when the function is greater than 0, that's going to be when it's positive, and that occurs when it is either less than 4 or greater than 2. When the function is less than 0 or negative, that occurs when it is between negative 4 and 2. So these would be the two possible solution ranges. The intervals determined by the zeros of a function are called the test intervals. In solving a quadratic inequality without graphing, we use a value of x in each of these test intervals to determine whether or not the quadratic function is positive or negative, as is shown below. So if I take the inequality x squared minus 9x plus 14 is less than 0. First thing I'm going to do is I'm going to determine the roots. Now I can use this using any of my quadratic methods, but I'm going to do it through factoring. So I'm going to say that if x squared minus 9x plus 14 is equal to 0, then that's going to be x minus 2 times x minus 7 is going to be equal to 0. And the two roots would be x is equal to positive 2 or positive 7. I'm going to use the roots to split this into the three regions. One region is when x is less than the smaller root. The middle region is when it's between the two roots, or the smaller root is less than x, which is less than the bigger root. And finally, when x is greater than the bigger root. Now from here, I can use a test value to figure out whether it would be positive or negative. So I can pick any value I want that is less than 2. I just can't include 2. So I'm going to go with a very simple one. I'm going to say, well, what if x was 0? And that's going to be pulled from this first one here. If x was 0, then I would say that 0 squared minus 9 times 0 plus 14, I can put all that in my calculator, and I'm going to wind up with is equal to 14. And that's a positive number. Next, I'm going to pick a number that's between 2 and 7. I'm likely going to use 3, 4, 5, or 6. In this case, I'm going to use 5. But any number that's in between them that does not include 2 or 7, you're good. And I'm going to say that, in this case, if I had 5 squared minus 9 times 5 plus 14, I can put all that in my calculator, and the answer I should get is negative 6. And finally, for my last region, I need a number that's greater than 7. So I'm going to use a nice round number. I'm going to use 10. And if I take 10 squared minus 9 times 10 plus 14, I put all this in my calculator and I get 24, which once again is a positive number. If I'm looking for the solution to the inequality, x squared minus 9x plus 14 is less than 0. If a number is less than 0, that means that it is negative. And my solution interval, I've already stated up at the top here. When is it negative? When 2 is less than x, which is less than 7. If I use the same table in order to state the solution for the other inequalities here, when would this be greater than 0? Well, it's greater than 0 when it's positive, and it's positive here and here, which means that it's going to be positive when x is less than 2 or x is greater than 7. When it says less than or equal to 0 or greater than or equal to 0, the only thing that changes is I need to include the equal to in my solution intervals. Other than that, it's the exact same. If I'm solving the inequality x squared minus, 8x minus x squared is less than or equal to 0, I'm going to start the same way. I'm going to state that 8x minus x squared is equal to 0. When I factor this, it's going to be x, and 8 minus x is equal to 0. And that means that x is going to be either equal to 0 or 8. Those are the two possible roots. Then I'm going to make a chart like what we had before. I'm going to say my interval up at the top. And I'm going to say the sine of 8x minus x squared. The first interval is going to give me x is less than 0. Second interval is 0 is less than x, which is less than 8. And then finally, x is greater than 8. When I sub in a test value for the first one, I'd use something like -1. For the second one, I'm probably just going to pick 1. And for the third one, I'd pick something like 10. Then this one is going to give me -9. This one is going to give me 7. And this one is going to give me -20 when I put it in my calculator. The first region is negative. Second region is positive. And the third region is going to be negative again. And when I look back here, it says that it wants it for when it's less than or equal to 0, which means that my correct region is going to be the negative regions. Because it includes an equal to in the inequality, I need to state that x is less than or equal to 0, or x is greater than or equal to 8.